So today we're going to talk about a few different things that we can use as conversions. And the first is going to be density. So density is the amount of stuff in a certain amount of space. So typically we think of density as how much mass, how much stuff per amount of space per volume. And so that means that density can be anything with a mass and a volume, a mass over volume. So you might see units like gram per milliliter or kilogram per pound. Oh, sorry, kilogram per meter cubed, pound per cubic inch, milligram per microliter. These are all density units that can be used. So if you see anything given to you with a mass and a volume unit, that's a density. Or if I'm asking you what is the density of something, you will need to find the mass, and then you will need to find the volume and divide them, because it's mass divided by volume. So anytime you're given something with where you would say out loud the word per. So for example, if I said water has a density of 1.00 gram per milliliter, when I would say this word here, per, I want you to think of setting this or restating it in your head as equals 1, because then you can turn it into an equality from that. So I can rewrite this as a conversion as 1 gram equals 1 milliliter. So instead of saying 1 gram per milliliter, I can say gram equals 1. So where I would say per, I say equals 1 instead. So this line here is the same as this. And now that I have an equality, right, I can use it as a fraction in dimensional analysis. I can put the grams on top, or I can put the grams on the bottom. And I can use that either way, because if two things are equal to each other, we can put them on top of each other in either order. Now, it's important to note here with density that the substance is the same on both sides. So for example, if I am saying this density of water, it would be 1 gram of water equals 1 milliliter of water. It wouldn't be like a gram of salt in a milliliter of water. Okay, that would no longer be a density. I mean, you could have that as a conversion, but it's not a density anymore. So a density is the mass of a thing and the volume of the same thing. So the substance is the same on both sides here when we talk about density. So keep that in mind as you are looking for word problems. What am I being given? What is it asking me for? If I ask you for the density of a substance, you need the mass of that substance and the volume of that substance. And in lab, we will talk about how to, or hope most of the time in labs, you will get different ways to find the masses and volumes, right? So you might have to weigh a beaker, then put a substance in, and then weigh the beaker and the substance to subtract out to find the mass of just the substance. But like when I'm talking about asking of the density of the substance, it's not the beaker and the substance for the mass. It's just the substance. So you may have to do some subtracting or some finagling of how you measure things in a lab to get the density of exactly just the substance we're asking for. So as soon as you ever see any slash between units like this, or if the question actually reads with the word per, that's a conversion factor. That is something you can use to convert between mass and volume or volume and mass. So we can use that as a conversion factor. Another thing we can use as a conversion factor is a dosage. And I specifically point this one out because many of you will be going into healthcare or nursing, and you're going to encounter lots and lots of dosages. So a dosage is just the amount of medication or substance. We'll just say medication here. And it's usually per amount of body weight. So for example, there's something called the effective dose. And then there's the LD50, which is the lethal dose in 50% of test subjects. So when a pharmaceutical company is thinking about, okay, how much medication are we going to put as the dosage for medication, we want to go above the effective dose, right? Because we want the medication to be effective, but we want to go as far below the lethal dose as we can. Most over-the-counter medications have a very high lethal dose because they don't want people to accidentally take too much and then have a lethal dose. If it is a prescription medication or a medication, especially given intravenously, like at a hospital, it may have a much lower lethal dose, which is why only nurses and doctors are allowed to give that medication. If the effective dose and the lethal dose are close together, that medication is very dangerous, right? Because it's easy to go over the lethal dose when you're trying to get to the effective dose. And so what dosages will typically look like, and I'm just going to give a random example, I'm making up numbers here, would be like 25 milligram per kilogram. And again, we see this per, right? So we can turn this into a conversion factor. We can say 25 milligrams equals 1 kilogram. And while you look at this in the context of I'm telling you a dosage, this would make sense. 25 milligrams of medicine per kilogram of body weight, because you understand what a dosage is. However, when you're using something in dimensional analysis, you have to make sure that your equality is true in any circumstances. And so if I were to just try to throw this into dimensional analysis, 25 milligrams equals 1 kilogram, that wouldn't be all that I need here. The thing that gets people confused about dosage math is these are both masses. And if these are of the same thing, then it's not true. So like if this is medication and this is also medication, that's not true that 25 milligrams equals a kilogram, right? And you know that because you know your SI prefixes, and that kilo is a really big prefix and milligram is a really small prefix. It takes a lot more milligrams to make a kilogram. Also, it would be base 10, so the 2 and the 5 wouldn't even be there. So we have to be more specific. So whenever you're dealing with dosages for this class or nursing class in the future or any class in the future, dealing with any conversion really, you want to be specific about labeling every part of your conversion. So we want to say 25 milligrams of what? Of medication is equal to 1 kilogram of what? Of patient body weight. Right? And you can abbreviate if you want to abbreviate med or BW for body weight or something. And this is going to be really helpful with you in setting up dimensional analysis, because when I tell you, hey, there's a patient that weighs 100 pounds, how many milligrams of medicine do they need? If I just put in, if I say 100 pounds into dimensional analysis, and I go, okay, well, I can turn pounds into kilos. I know 2.205 pounds is a kilo, right? And then I can say, oh, I can turn kilogram into gram. And then I can turn gram into milligram. Whoops. Right? And so now what I've done is I have answered your question, and this is, hopefully you were able to follow along how I'm putting things around there. I'm just showing you how you can kind of do this wrong. What I've done over here is I've turned it into milligrams, which is maybe what the question's asking. But look at what I've done. I've taken the body weight of the patient. This is still body weight of the patient. This is still body weight of the patient. So that means this is still body weight of the patient. I'm just converting 100 pounds of body weight into milligrams of body weight. If you give your patient this many milligrams, that's going to be an overdose, because you're giving them their body weight of medication. So you have to be careful. So the correct way to set this up would be 100 pounds of body weight. Now I use my conversion. I know that I need to change pounds to kilograms. Again, it's of body weight. Now I can say a kilogram of body weight is 25 milligrams of medicine. Use the dosage. Now that will give me milligrams specifically of medicine, not milligrams of body weight. There's a difference here in the answer and in the probability that you're going to overdose your patient if you're doing the math like this. So label not just the unit and the number, but what am I talking about? And later on in chemistry, you're going to need to label things, because we're going to be changing substances and chemical reactions and whatnot. And so you'll need to make sure everything has a label. So think about what number you need, what unit you need, and what substance you need. Another thing to note here is that you cannot cancel kilograms of body weight with kilograms of medicine, for example. It has to be the same exact thing in order to be canceled. And so think about setting it up with the labels as well as the units. So we're kind of expanding on that dimensional analysis here to make sure that you're really understanding each little step. So write a little bit more. And if you need to stack it on top of each other like this to save space on your page, that is something that I do that is helpful. Another thing that we have to do in considering labeling is labeling percentages. So let's talk lastly about using percentages as conversions. So a percent is always a fraction, part, over some whole times 100. That's what a percent is. So if I have some number here of percent, and I want to get rid of the percent sign, and I just want to talk about it as a fraction, which then can be used as a conversion factor, I can do a couple of things. So if I divide both sides by 100, I would get whatever my number is out of divided by 100 is now equal to the part over my whole. And then I can use this as a fraction. If you don't know what the whole is, you can assume 1. Another thing that I like to do to turn a percent into a conversion easily, and to get rid of this 100 here, is to just assume that the whole is 100. Because if the whole is 100, now the part is equal to the number, because the 100s would cancel out and I'm left with the number equals the part. And so let's look at an example to make this a little more clear. So if I have, let's say 25% of the soda is sugar. Let's write that as a conversion factor. We can do two ways. We can move the decimal over and we can say, 0.25. Let me give you units here. Let's put some units in here. My apologies. Let's say mass volume percent. So if I say mass volume, let's use units of mass over volume. So kind of like density, but it's going to be different substances on either side. Let's use grams and milliliters. So I can say 0.25 grams of the sugar in 1 gram of soda. However, I think it's better to just keep the number 25 and assume 100 of whatever your whole is. So let's just break it down. I'm going to break it down into pieces for you. What's the part here and what's the whole? If I say 25% of soda is sugar, the whole thing is the soda. The part is the sugar. So we have 25. We use mass for the part and we use volume for the whole because it's part over whole here. So we'll say 25 grams of sugar and we'll say 100 grams of soda. So we can use it as a fraction like this, or we can write it as an equality. You know, I enjoy writing it as an equality because that's going to lend itself to more flexibility for you. Do you need to put soda on top of a fraction? Do you need to put sugar on top of the fraction? Not sure. Just write it as an equality. So you can put it out of 1 and move the decimal over. For many students, that's a little more difficult to break down. I say, break down what is the part, what is the whole, write it out if you need to understand it. Then say, okay, well, the part is the sugar. What number goes with sugar? Well, the percent is always the number that goes with the part, because if we assume our whole here, the percent and the part are the same because the 100s cancel out, right? So the part and the percent wind up being the same number. So we have 25% is going to be 25 of sugar. Oops, and I put grams here and I meant to say milliliters. Ignore me today. Okay. And then you look to the information of after your percent to give you your units. And sometimes you won't be given this information, but the rest of the question will help you figure out what units that you want, or it'll say like by mass or by volume. If it says something by mass, then both of your units are mass units. Just use grams. If it says by volume, both of your units are volume units, just use milliliters. Those are the common units in chemistry, grams and milliliters. You can use any unit you want as long as it's the same on both sides, but we typically use grams and milliliters for chemical purposes. So now you have a conversion of a percent. So we have this 25%, we have a conversion factor here. The reason why I like to think about percents as conversions is because many people know how to use percentages when I'm asking you, like, what is the part? So for example, I have this 25% soda is sugar. How many grams of sugar in 250 milliliters of soda? And many people can do this maybe in their head or in a calculator and say, well, if we know that 25% of soda is sugar, then I'll just take 25% of this, right? And you can do that in the calculator, or you know that you can push your decimal back 2 times and multiply 0.25 by 250. If none of that makes sense to you, fine, great. Just don't do it that way unless it makes sense. But however, to show you how this would look in dimensional analysis, this is going to be my starting place here. So my start is going to be 250 milliliters of soda. Notice that I'm writing what the substance is. I can't say 25 grams equals 100 milliliters. You have to say sugar and soda or it's not actually equal. We have to be more cognizant of making sure we write those labels down. My unknown and where I'm going to end is grams of sugar, not just grams of soda, grams of sugar. I don't have a relationship. I don't have the density of the soda. So I can't go from milliliters of soda to grams of soda because you're not given the density. You're given the percent between soda and sugar, between the part sugar and the whole, the soda. A conversion that I have is my percent. 25 grams of sugar in every 100 milliliters of soda. So when I put this together, I wind up doing maybe what some of you did in your head, which is just taking 25% of 250. So we divide our percent by 100, and then we multiply it by what we want to take the percent of, right? You'll get the same answer if you did it kind of in your head or just in the calculator by taking 25% of 250. But what if I ask you the opposite direction? Let's just do sig figs for this really quick pause and see if you can think about sig figs here. The 100 is infinite sig figs because that's part of the definition of a percent. Here we need 2 sig figs. If you're not sure about that, you send me a text message really quickly asking about the sig figs for this if you're not sure why it's 2. Let's look at one more example. What if I said, how many milliliters of soda would contain, I don't know, 52 grams of sugar? Now, this is a little bit more difficult. And I bet that if you did the first one in your head, this one is going to be more difficult to do in your head because you can't just take 25% of 52. It's the opposite. So in this case, if you want to try setting up your start unknown conversion, you can, but it's very similar to the top one. I'm going to start with the 52 grams of sugar. But now look at how my conversion is written. It's the 25 on the bottom. And that's hard to see or hard to think about in your head if you're just used to using percent math like we use it in real life, which is usually just taking percentages of something. So here, it's a bit different. We have a little bit of a sig fig problem here. I want you to pause and think about it. You need 2 sig figs. How are we going to get 208 to turn into 2 sig figs? Can you say 21? What about 20 with a decimal after? 208, just leaving it like that. 21 and 20 are not the same value as 208, so we can't round that way. You also can't leave it Q208 because we need two significant figures, one from the 25% and this two significant figures from your starting place here. So we have two options. You can look at this and say, well, 210 is close, and just rounding up the 0 here to 1, but keeping the same value places, the same decimal values. So this stays in the hundreds place, this stays in the tens place, this stays in the ones place. Or you can put 208 into scientific notation by moving the decimal back 2, and it's going to be a positive exponent because 208 is greater than 1. Then we cut off for sig figs, which is actually the same thing as 210. So you could write it either way to get your two sig figs. Good work. Thanks for watching. Let me know if you have any questions.